Chapter 2, Force and Pressure. Learning objectives are repetitive motion, periodic motion, non-periodic motion, objects having more than one type of motion. First, repetitive motion. What is repetitive motion? When an object moves such that it repeats its motion after certain interval of time, it is said to be in repetitive motion. That means that objects moving repeat the particular interval of time, that is called repetitive motion. Repetitive motion, there are two types. One is periodic motion, another one is non-periodic motion. Further, periodic motion, example of simple pendulum, and non-periodic example of oscillatory motion and random motion. First, periodic motion. What is periodic motion? Periodic motion repeats itself after a fixed interval of time. That is important. That means, suppose example, a simple pendulum oscillate. That oscillation, the interval should be equal. So, periodic motion repeats itself after a fixed interval of time. Example of Earth rotate itself on its axis. And second one is the Earth rotate itself at the same time it is around the sun also. Third one is moon. Moon is the satellite of our Earth. So the moon also around the Earth. So these are the example of periodic motion. That means this motion, it will be taking regular interval of time. That is called periodic motion. Simple pendulum. A simple pendulum consists of a metal ball, that is called a bob, suspended by a long thread from a rigid support, such that the bob is free swing back and forth. The motion of pendulum was first studied by Galileo Galilei. That is important. Maybe the 1 mark will become discovered the importance of principle of pendulum, according to which a simple pendulum completes every swing or every oscillation in exactly same time, provided its length is kept constant. Length of the pendulum. The distance from the point of suspension to the center of bob is called the length of the pendulum. In other words, the length of pendulum is the length of the thread plus the radius of the bob. It is denoted by L. Okay. Suppose see one of the example. This is the thread, rigid support. This is called a bob, a pendulum. See, the length of the thread plus radius of the bob, it is denoted by the letter is L. Oscillations. One complete to and fro movement of the pendulum bob is called an oscillation. What is to and fro? That is the movement from left to right. That is called, we will say, to and fro. One oscillations can be counted starting from one of the extreme position. It is very, very important. The extreme position of the bob. The motion of the pendulum bob, its extreme position B to C and back to B is called one oscillation. I will show you further example. See here. Suppose B, any one of the side B or C. Suppose now you take the bob B, it is the extreme position. OA is the mean position and B is the extreme position. Suppose this is the extreme position. When I release, this bob make to oscillate. Suppose this bob goes to at the point of B and return come back to B. So this is called one oscillation. See here. C and come back to B. This is one oscillation. Amplitude. As the pendulum swings to and fro, the maximum displacement of the bob from its central position or mean position on either side, maybe B or C, is called amplitude of the pendulum. So O is the mean position. From the A, we will move any one of the side, either B or C, that is the extreme position. So from the distance between mean position to extreme position, this is called amplitude. The distance AB or AC is the amplitude of the simple pendulum. Frequency of oscillations. The term's frequency tells us the rate at which simple pendulum is making oscillations. The number of complete oscillations made by a simple pendulum in 1 second is called its frequency. The SI unit of frequency is Hertz. Very important. The SI unit of frequency is Hertz. 1 Hertz is equal to 1 oscillation per second. Time period. The time taken by the pendulum bob to make one complete oscillation is called the time period of the pendulum. The time taken by the bob to travel from the position B to C and back to B is the time period of the pendulum. It is denoted by the letter T. Already we know length we denoted by the letter L. Here the time we will denoted by the letter T. Formula for the time period, that is T is equal to 2 pi square root of L divided by G, where 2 pi is the constant, where T time period of the pendulum by is equal to 22 by 7 or 3.14. It is a constant. L is equal to length of the pendulum. G is equal to acceleration due to gravity. Non-periodic motion. A motion which repeats itself but not at a regular interval of time is called non-periodic motion. For example, already we know about the cricket. Yes or no? So, in cricket, the two batsmen running on the time, the speed will be different. See here, one of the batsmen will be moving some of the speed, another one of the batsmen move another one speed, so the speed will be different. So this is one example of non-periodic motion. Another one example, the trees movement, that is to and fro. So sometimes we can see the Kajastro on the time you will observe the trees moving from all the side, from one side to another side. So this is one example of non-periodic motion. And example of balls. Suppose we throw the ball into the ground, it is jumping. So we will take different types of balls. Example of see red color ball, blue color ball, yellow color ball. All the balls will be thrown into the earth. All the balls will be jumping different height. So this is one example of non-periodic motion. Oscillatory motion. If an object moves in a to and fro motion about its mean position, it's said to be in oscillatory motion. Oscillatory motion, and if an object moves in a to and fro motion about its mean position. Example of swing. Simple pendulum, moving of a fan. So these are the examples. Oscillatory motion. Random motion. When an object moves any direction and the direction keeps changing continuously, it is said to be in random motion. Suppose example of kite. Already you know well about the kite. Already you are experienced playing in kite. So on the time you will observe your kite will be moving from one side to another side So you can feel that. So these are the example of random motion. And another one example of fish. Suppose the fish moving under the water, or you can see in aquarium, the fish moving from one side to another side, it is random motion. Object having more than one type of motion. That means some objects may have more than one type of motion at the same time. In other words, some objects may have a combination of two or more different types of motion. The motion of the earth. The motion of the earth moves around the sun, so it has circular motion. The earth repeats its motion around the sun after regular interval of time, 1 year. So it has periodic motion. The earth rotates on its axis, so it has also rotational motion. Simply we will say, I will explain to you the motion of the earth. See here, the first you can see the earth rotate itself, at the same time it is around the sun also, so that the motion of the earth having three type of motion. One is circular motion. See here, the earth rotates around the sun in the orbit in the form of circular motion, and the second one is periodic motion. It is continuously moving, yes or no? Every year it is continuously moving. And third one is rotational motion, yes or no? So the suppose one example of the motion of the earth, three type of motion: circular motion, periodic motion, and last one is rotational motion. The motion of a merry-go-round. The motion of a merry-go-round shows rotational motion because it turns on an axle. Suppose we can see in our school also having merry-go. The center of the part attached to the ground. It is fixed axle, but the outer part of the merry-go-round on which children sit shows circular motion. Suppose when we look the children, the motion should be circular, but when we see the merry-go-round fixed axis, that is called a rotational motion. So the motion of the merry-go-round having two types of motion. One is rotational motion and another one is circular motion. So these are the example. Okay, so when we see this boy, circular, look like a circular, but merry-go-round rotational. The motion of a bicycle. Suppose a bicycle is moving on a straight road. When we look, the wheel is rotating on its axle and also moving forward in a straight line path. So rotational motion and rectilinear motion. When you see the wheel, rotational, fixed on the axle, and a rectilinear, it is moving in straight line. Now yes, straight line. So the cycle moving on the straight road, rectilinear motion. The motion of a ball. The motion of a ball having two type of motion. One is rotational, so the ball is rotating, and another one is rectilinear. Rectilinear means goes to in straight line path, so the ball is coming straight line. Okay, yeah. The motion of a sieving machine. The motion of a sieving machine having two type of motion. Suppose when we see the wheel, it is a rotational motion, but when we see the needle, it is continuously moving up and down, so this part, so it is periodic motion. So the motion of a sieving machine having two type of motion. One is rotational and another one is periodic motion. Thank you, students.